Welcome back guys to Economics, and in this video let's solve the marginal rate of substitution for a simple Cobb-Douglas utility function, which is a numerical example. Suppose we have a Cobb-Douglas utility function u of x of y, u of xy, which is equal to x to the power of 0.3, y to the power of 0.7. What will be the marginal rate of substitution for this Cobb-Douglas utility function? We know that the marginal rate of substitution is equal to marginal utility of x divided by the marginal utility of y, which the marginal utility of x is equal to the partial derivative of utility function with respect to x, and the marginal utility of y is equal to the partial derivative of utility function with respect to y. So now let's find it. This one is equal to, let's take the partial derivative of this function with respect to x first, which is 0.3 multiplied to x to the power of 0.3 minus 1 multiplied to y to the power of 0.7. Then let's take the partial derivative of utility function with respect to y, which will be equal to 0.7 multiplied by x to the power of 0.3 y to the power of 0.7 minus 1. So now we have 0.3, then x to the power of 0.3 minus 1, we will have minus 0.7, and y to the power of 0.7. And here we have 0.7 x to the power of 0.3 y to the power of 0.3 with negative sign. So now we will have the marginal rate of substitution is equal to 0.3 over 0.7 multiplied by, so now we have y to the power of 0.7, so keep that one, y to the power of 0.7, move this y to the power of minus 0.3 to the numerator, which will be equal to y to the power of 0.3, and we have x to the power of 0.3 multiplied by x to the power of 0.7. So now it's 0.3 divided by 0.7. So now y to the power of 7 multiplied by y to the power of 0.3 will be equal to y. And x to the power of 0.3, x to the power of 0.7 will be equal to x. So it's equal to 0.3y divided by 0.7x. So this is the marginal utility, the marginal rate of substitution for this utility function. You know that here the marginal rate of substitution of this Cobb-Douglas utility function depends on the value of x and y. It depends on how much x and y we have in our like consumption bundle. So if we have more y and x, so the value will be different than if we have less y and x. So that's why in the Cobb-Douglas utility function, the marginal rate of substitution depends on how much x and y in our consumption bundle we already have. So I hope now you clearly understand how we can find out the marginal rate of substitution for a Cobb-Douglas utility function. I hope to see you guys in the next video, and hope to not forget to subscribe my YouTube channel in order to enjoy other videos as well. See you next time.